Hi, welcome once again to our YouTube channel. Thanks for subscribing to our channel. We really appreciate it. Today we quickly want to take some sample questions in WAEC 2025 quantitative analysis, which is the titration. We quickly want to use some questions to actually make ourselves familiar with possible questions that will be coming across in the titration examination, and so we use these sample questions to actually prepare ourselves as to what the examination will be looking like. Before we go into doing that, listening out our questions, let us quickly see a couple of things that can help us in answering questions. And talking about useful formulas in volumetric or quantitative analysis. Here we have some formulas that have been itemized that could be very handy in writing the examination. Now, we have mass concentration. As we can see here, the formula for mass concentration is molar concentration times molar mass. That is the formula for mass concentration. And if we are looking for molar concentration, we can actually make molar concentration the subject of the formula in this particular equation here to be able to get its own formula to be mass concentration divided by molar mass. We could also be looking for molar mass, which would then be mass concentration divided by molar concentration. We have concentration here. Concentration can be calculated using mole divided by the volume in dm cube of the substance that is used or that is to be calculated. We also have another formula which could be used in calculating concentration in moles per dm cube. We could be using CAVA. CA there is concentration of acid, while VA is the volume of acid used. Concentration of divided by the concentration of base multiplied by volume of base of the substance, and then which is equal to Na, that's number of moles of acid over number of moles of base. Number 5 there says percentage purity. Sometimes we could be asked to calculate the percentage purity of the substance that is in reaction. So to calculate percentage purity, we make use of this formula, which is mass concentration of pure substance divided by mass concentration of impure substance multiplied by 100 over 1. Also, we could be looking for the percentage impurity in the substance. If what we are looking for is percentage impurity in the substance, we will be having it to be 100 minus percentage purity. Remember, in number 5 here we calculated percentage purity. So if you are looking for percentage impurity, since percentage is over 100, all we need to do to get percentage impurity will be to subtract the percentage purity from 100, and that will give us the percentage impurity of that substance. And quickly we go to talk about this. The next formula there, that's solubility of the substance that we'll be looking at, which is sodium hydrogen transocarbonate in moles per dm cube. Solubility of sodium hydrogen transocarbonate in moles per dm cube can be calculated using C1V1 equals C2V2, where our C1 is unknown and our V1 is the first volume of the substance in dilution, while our C2 is going to be the concentration of the base that has been gotten from the question or that has been calculated and figured out, and then V2 will be second volume, which is oftentimes in 1000 centimeter cube or 1 dm cube for the dilution. So that is about solubility. And then number 8 there talks about dilution principle formula similar to solubility of the substance here. We have it to be C1V1 equals C2V2. And then number 9, we could be asked to calculate mass of salt that is formed. Since it is a neutralization reaction, we could be having we'll be having the formation of a salt. So how do we then calculate the mass of the salt that is formed? This is calculated by using the concentration of the base multiplied by the volume that is given in dm cube. The volume that is given in dm cube, not the volume of the base per se, but the volume that is given in dm cube, then multiplied by the molar mass of the salt that is formed. Definitely the salt that is formed will have its own molar mass, which will be calculated. I'll show us how to do that shortly. And then number 10, we have volume of gas at STP. This volume of gas at STP can be calculated using the concentration of base multiplied by the coefficient of the substance. Oftentimes it is going to be carbon dioxide, particularly in this case it is going to be carbon dioxide, and then it is going to be multiplied by the volume given in dm cube. There also not the volume of the base, and then also multiplied by the molar volume of the gas at STP, which is 22.4 dm cube. That is Avogadro constant. So these are some formulas that will come handy while answering questions in this particular segment. Now, here are some indicators and their colors in solution. We have some indicators that are used in titration and oftentimes this could come in your question 3 in the practical examination. You could be asked to discuss or to talk about some indicators and their colors in some different in solutions. So for methyl orange, we have different types of indicators. We have methyl orange, methyl red, phenolphthalein, bromoethymol blue, etc. So we could be using any of them for the titration that we are looking at. But for the difference, I'll show that to us shortly. Whenever we have strong acid to strong base, there are types of indicators that are most suitable for such reactions and the rest of those. So methyl orange in acid, when you drop methyl orange as an indicator into acid, it gives a pink coloration, while in base, methyl orange will give a yellow coloration. Methyl orange at end point or neutral is always orange. If it were to be phenolphthalein is oftentimes used for a titration between a weak acid and a strong base. In that reaction, phenolphthalein in acid is colorless. When it is dropped in base, it gives a pink color, and then at neutral or end point, it is usually colorless again. Bromoethymol blue in acid is yellow. When it is dropped in base, it gives a blue color, and then when bromoethymol blue is at end point, it also gives a green color. That is about the color changes of these indicators in different solutions. And here I was talking about the types of titration and the different types of indicators that could be used for them. So if you look at this one now, for strong acid versus strong base, any indicator can be used for such reaction. Any indicator, be it methyl orange, methyl red, phenolphthalein, bromoethymol blue, any indicator at all can be used for this type of reaction. But when we're looking at strong acid and a weak base, the most suitable indicator for such reaction, like the one we'll be having shortly, is going to be methyl orange. And then reacting weak acid with strong base, use phenolphthalein, and when it is weak acid to a weak base, no suitable indicator is found or used in this particular reaction. So I want to make this a prelim to what we will be looking at in the course of this particular tutorial session. So we have some sample questions that we will be using. This is one of the sample questions that we'll be using to answer some questions. So let us dive straight into that. Now, there are some basic rules that we need to know about this titration. Number one, what we'll be working with, we have our sample A. Sample A, which is our acid. Sample A, which is our acid. Our acid is HCl. Our acid is HCl. So if you want to calculate the molar mass of HCl, this is how it is done. With this now, we have these are some of the things that we will be seeing in this reaction. Our hydrogen has a mass of 1, and then we have chlorine with a mass of 35.5. We have our sodium to have a mass of 23. We have our carbon to have a mass of 12, and then we have our oxygen to have a mass of 16. So with all of these informations here now, we can actually calculate the molar mass of some of these substances. So in the case of hydrochloric acid, this is how the molar mass will be calculated. Molar mass of hydrochloric acid, we have it to be 1 plus our chlorine is 35.5, and that will give us 36.5 grams. That will be the molar mass of our acid. And then our sample B, our sample B, which is our base, is sodium hydrogen triisocarbonate. That is our B. And so for the molar mass now, molar mass of B, that's our sodium hydrogen triisocarbonate. This is how it will go. Sodium is 23 plus our hydrogen, which is 1, plus our carbon, which is 12, plus our oxygen, which is 16, but 16 times 3. You can see that oxygen has what? 3 atoms there. So this is what the substance is going to look like. So from here now, we have 23 plus 1, that's 24, plus 12, that is 42. We have 23 plus 1, which is 24, plus 12, which is going to be 36. 36 plus 16 times 3 gives us 48. So that gives us a total of 84 grams. So that will be the molar mass of sodium hydrogen triisocarbonate, which is our base. So now that we have talked about this, we have known how to, we've taught ourselves how to calculate the molar mass of the substances. Let us now quickly look at the reaction proper. Let's look at the equation for the reaction. So equation for the reaction. Equation for the reaction. Since it is an acid-base titration, that particular type of reaction is going to be a neutralization reaction. So this is what we will be having. We have HCl reacting with sodium hydrogen triisocarbonate. Sodium hydrogen triisocarbonate. So in this particular reaction, we'll be having the formation of a particular salt, which is going to be sodium chloride in this case, and then we'll be having water and carbon dioxide. So we'll be having carbon dioxide plus water. This is what the reaction will be looking like, and if you look at it, all of them are in ratio 1:1. Ratio 1:1. One of hydrochloric acid, one of sodium hydrogen triisocarbonate, one of sodium chloride, one of carbon dioxide, and one of our water. That is what the equation for the reaction will look like. So quickly we move to the question proper now, and the question there says A is a solution of HCl containing 3.9 grams per dm cube, and then B is a solution containing X gram per dm cube of sodium hydrogen triisocarbonate. Put A into the burette and titrate it with 20 or 25 centimeter cube portions of B using methyl orange as indicator. Repeat the titration 3 more times to obtain concordant titral values. Tabulate your results and calculate the average volume of acid used. From your results and the information provided, calculate the following. 1. Concentration of A in moles per dm cube. B. 2. Concentration of B in moles per dm cube. 3. Mass of salt formed when 500 centimeter cube of B is completely neutralized by A. And then Roman numeral 4, we have to calculate the value of X in that substance. Remember that our X is not given, so we have to calculate the value of X. So like what we wrote just minutes ago, this is the reaction equation here. We have hydrochloric acid reacting with sodium hydrogen triisocarbonate to give us sodium chloride. In aqueous form, we have the water and then carbon dioxide. So that is what our reaction is looking like. So for this particular reaction, we'll be making use of 23.80 centimeter cube as our average titral value. That is what we'll be using as our average titral value. I want to believe we know how to carry out our titration proper and to conduct to create our table. Perhaps you do not understand that properly. You can quickly look at the video that the link is showing on the screen right now to help you understand how titration is being carried out and how the table is being constructed. So for this question, let us move straight into it. So we said our A question 1. We said our question 1 has its A to contain the mass concentration of A equals 3.9 grams per dm cube, and then that of B equal X gram per dm cube. That is what we have from that particular question. Now we will always have our VB. Let's have VB for this one to be 25 centimeter cube. 25 centimeter cube. We have our VA, which is our volume of acid used, according to this question, we said we are using 23.80 centimeter cube. And then we have our NA. These are some facts. We have our NA to be 1 and our NB is also 1. Now, calculating the value that we are to look for now, concentration of A in mole per dm cube. This is what we'll be looking at. Concentration of A in mole per dm cube. The formula we'll be using is going to be Ca equals mass concentration of A. What we want to use right now is, let me just put that here. We have mass concentration which is in grams per dm cube, because molar concentration, mole per dm cube multiplied by molar mass, which is usually in grams per mole. That is the formula that we will be using. So for us to make use of this formula now, we are looking for concentration of A in mole per dm cube. This is what we are actually looking out for here. This one here, mole per dm cube, molar concentration. So let us use this one to make our formula now. Molar concentration equals, we have mass concentration divided by the molar mass, mass concentration of A, we got 3.9 from the question. It said 3.9 grams per dm cube divided by the molar mass of A. Here we calculated the molar mass of A to be 36.5 grams. So that is what we are using here, 36.5 grams. So when we do that now, what we'll be having is going to be 0.1068, and these three significant figures will be having it to be 0.107 moles per dm cube. That is what our answer will be, 1.017 moles per dm cube, because we are looking for the molar concentration of the substance. So that is going to be our answer here. So that is that. And then let's go to the second question. Number 2, that says the molar concentration of B, the concentration of B in moles per dm cube. Concentration of B in moles per dm cube. Remember, we listed out some of the important materials that we have. We can see all of this here. So we are going to be making use of this now to answer this particular question. So we have our molar concentration for A now to be 0.107 moles per dm cube. So that information is going to be added to all of the informations we have here, such that we will have this to be the formula. This is the formula that is to be used. We have CAVA over CBVB. CBVB equals NA over NB. That is the formula we are to use. So from this now, we are looking for concentration of B. So let us make this subject of the formula. For us to do that, we need to make this a straight line equation. And making it a straight line equation, we need to cross multiply. So cross multiplying now, we'll be having CAVANB equals CBVBNA. And then making our CB subject of the formula, we'll be having CAVANB all divided by the coefficient of CB, which is going to be VBNA. From here now we can input our values. Our CB equals, what is our concentration of A? That is what we calculated here to be 0.107 moles per dm cube. So 0.107 multiplied by our volume of acid used. For the question here, we said we are making use of 23.80, 23.80, and our NB, number of moles of acid of base, is 1, and then all divided by, we have all this divided by all of this is divided by the volume of base, which is 25 centimeter cube, and then number of moles of acid, which is 1. So when we carry out this calculation, we'll be having 2.5466 divided by 25. That will give us 0.101864, and then these two three significant figures will give us 0.102 moles per dm cube. That is going to be the value of our substance, that is concentration of B in moles per dm cube. That is the answer there. And then we move to the next question, which is Roman numeral 3. Roman numeral 3. The question there asked us to calculate. It said calculate the mass of salts formed when 500 centimeter cube of B is completely neutralized by A. The mass of salt formed when 500 centimeter cube of B is completely neutralized by A. So doing that now, we say mass of salt formed when 500 of B is neutralized by A. What we'll be having there, we have written the equation for the reaction before. So the salt that is formed from that equation, this particular equation here, the salt that is formed is this one here. We have this one to be the salt formed. So sodium chloride. So let us quickly look at that now. Sodium chloride is the salt formed. So salt formed in the above equation, salt formed in the equation reaction is sodium chloride. So let us calculate the molar mass of sodium chloride. Molar mass of sodium chloride. We said our sodium is 23 and our chlorine is 35.5. So having that now, we say that the molar mass of sodium chloride is 58.5 grams per mole. That is the molar mass of sodium chloride. Formula to use: mass of salt formed, put it this way, mass of salt formed equals, we have molar mass of salt multiplied by concentration of base, that is concentration of base in moles per dm cube, multiplied by the volume in dm cube. Volume in dm cube. Now the mass of salt formed there, mass of salt formed We said our molar mass, the molar mass of the salt is 58.5 times the concentration of base. Here we calculated the concentration of our base to be 0.102. That's what we'll be using here, 0.102 multiplied by the volume in dm cube. The question there told us that it is 500. You can see it here now. They said mass of salt formed when 500 centimeter cube is completely neutralized in A, and A is 1 dm cube, so we neutralize that in A. So the value we're given is 500 divided by 1000. So here we'll be having this now, 58.5 multiplied by 0.102 multiplied by 0.5. From here now, what we will be having is going to be 2.9. When we do the calculation, we'll be having 2.9835, and then to three significant figures. What we'll be having will be looking like 2.98 grams. That will be the reaction. And then let's take the last question. It says calculate the value of S, and look at it here now. Our X here is in grams per dm cube. So the mass concentration of B is what we are looking out for. So value of X. So how do we get that now? Since we have calculated some things before, let us look at this. Value of X. Value of X. That is the mass concentration. Mass concentration of B. Now, this is what we'll be using. We are using mass concentration, which is in grams per dm cube. It equals molar concentration in moles per dm cube times molar mass, which is in grams per mole. So since what we are looking for is the mass concentration, we can just go ahead using this. So from the question that we have, we said our molar concentration, after calculating, we calculated our molar concentration to be 0.102 moles per dm cube, and then we calculated the molar mass. The molar mass of B to give us 84 grams. So using these two parameters now, we can actually go to calculate the mass concentration. The mass concentration will now be our molar concentration, which is 0.102 multiplied by our molar mass, which is 84. So doing that calculation now, we'll be having it to be 8.568, and then these two answer in three significant figures. So that in three significant figure, we have it to be 8.57 grams per dm cube. So this is going to be the value of our X, or the mass concentration of B. So that is our answer there. So that is about question 1. So for our second question, the question there says A is a solution containing 1.88 grams hydrochloric acid per 500 centimeter cube of solution. B was prepared by diluting 50 centimeter cube of a saturated solution of sodium hydrogen trisulcarbonate at room temperature to 1000 centimeter cube. Put A into the burette and titrate it with 20 or 25 centimeter cube portions of B using methyl orange as an indicator. Repeat the titration 3 more times to obtain concordant titra values, and then tabulate your results and calculate the average volume of acid used. From your result that has been gotten and from the information provided in the table, calculate the following. Roman numeral 1, concentration of A in moles per dm cube. B, concentration of B in grams per dm cube. 3, solubility of sodium hydrogen transcarbonate in moles per dm cube. And 4, calculate the volume of carbon dioxide that will be liberated from 1 dm cube. Sorry, this is supposed to be 1 dm cube. From 1 dm cube of B if the titration were carried out at STP. So without wasting our time, let us quickly go to that. Now in the question, they said we should make use of 23.90 as the average titral value for this particular question. So let us quickly write what we have from the question. We said we have our A to contain 1.88 grams HCl per 500 centimeter cube, and then the B was prepared by diluting 50 centimeter cube of saturated solution of sodium hydrogen transcarbonate at room temperature to 1 dm cube. So from that now we have this. We said A contains 1.88 grams per 500 centimeter cube. It is very, very important that we know that. So for us to be able to calculate the concentration of A in moles per dm cube, we need to first of all calculate the volume of our A in dm cube. This is in 500 centimeter cube, so we need to calculate it in 1 dm cube. So let me solve A in grams per dm cube. Concentration of A in grams per dm cube. Now for us to do that, the question that says 1.88 grams was in 500 centimeter cube. So if 1.88 grams is 5 centimeter cube, what is going to be the value of A in 1000 centimeter cube, which is also our 1 dm cube? What will be the value? All we need to do is to cross multiply. So when we cross multiply, we will be having this. We'll be having x gram equals 1.88 multiplied by 1000 divided by the coefficient of x there, which is going to be 500 centimeter cube. So from that now, what we'll be having is going to be, we'll be having 1880 divided by 500, and that is going to give us 3.76 grams per dm cube. 3.76 grams per dm cube. So that is going to be the volume, the concentration of our acid in grams per dm cube. So now that we have this, we can now go ahead to calculate our concentration of A in moles per dm cube. Concentration of A in moles per dm cube. So how are we going to do that? We are going to be making use of the formula mass concentration equals molar concentration times molar mass. That is what you'll be using. So since what you are looking for is molar concentration, we are looking for molar concentration, so that will be mass concentration divided by our mass concentration divided by the molar mass divided by molar mass. So from what we have gathered, our mass concentration is what we just calculated here to be 3.76. Then 3.76 divided by the molar mass of our substance here, hydrochloric acid, is 36.5. So doing this now, we'll be having our answer to be 10301, and these two three significant figures now, we'll be having it to be 0.103 moles per dm cube. So this is going to be the value of our A, our concentration of A in mole per dm cube. without wasting our time, we move to the next question. The next question there is asking us to calculate the concentration of B in grams per dm cube. Concentration of B in grams per dm cube. So since we have all of this, let me split the board here again, or let me just put them up here. We have our CA. Now what we just calculated is our CA, and we said it is 0.103 moles per dm cube. 103 moles per dm cube. We do not have our CB. That is what we want to calculate. We do not have our CB. We have our VA. Our VA from the question, we are told to use 23.90 centimeter cube. Our VB is 25 centimeter cube. Our NA, we have it to be 1, and our NB is also 1. So with this now, we can actually calculate our concentration of B in grams per dm cube. But for us to be able to do that, we need to calculate our concentration of B in moles per dm cube first, because what we have in the question there has not given us anything to go by. So let's calculate our B in moles per dm cube, then we'll calculate it in grams per dm cube. So calculating in moles per dm cube now. Calculating B in moles per dm cube. Let us make use of this formula. CAVA equals CAVA over CBVB equals NA over NB. Let us use this formula. From here now, we can have a straight line equation that will be CAVANB equals CBVBNA. And from here, what we're looking for is CB. So let's make CB subject of the formula. CB equals CAVANB all divided by VBNA, which is the coefficient of our CB. And so here we can input our values. Now all of these values here, our CA is 0.103 multiplied by our VA, which is 23.90 multiplied by 1, all divided by VB, which is 25 times 1. And so from here now, what we'll be having is going to be 2.4617. We have 2.4617 divided by 25 that will give us, we'll be having 0.098468 thereabouts. And so all of these to 3 significant figures now. That will give us 0.0985 moles per dm cube. So this is going to be our CB. So from this now, we can now calculate what our CB will be in grams per dm cube. So calculating that now, let me quickly do this. So calculating concentration of B in grams per dm cube. Calculating B in grams per dm cube. You can now make use of this formula. Mass concentration equals molar mass or molar concentration times molar mass. So from that now, we see that our mass concentration equals the molar mass of B. The molar concentration of B is what we just calculated here now to be 0.0985 0.0985 multiplied by the molar mass of B, which is 84. So 0.0985 times 84 will give us 8.274. 8.274 to 3 significant figures now will give us 8.27 grams per dm cube. That is going to be our CB in grams per dm cube. That's going to be our value of B in grams per dm cube. And then we move to the next question, which is talking about solubility of sodium hydrogen triazocarbonate. Solubility of sodium hydrogen triazocarbonate in moles per dm cube. In mole per dm cube. So the formula that is to be used we are to use C1V1 equals C2V2. Our C1 is unknown. We do not know our C1, but we know our V1, which is in the question that is given to be 50 centimeter cube. Look at it here. They said that B was prepared by diluting 50 centimeter cube of this particular substance in 1000 centimeter cube. So this is our V1, and this is going to be our V2. That is how that is going to be. So we have this one to be 50 centimeter cube, and then our C2 in that substance there, we have it to be concentration of our B that has just been calculated, but the one in moles per dm cube, which was calculated to be, let me put that here, CB in mole per dm cube, and that is 0.0985. That is our CB, and then our V2 is 1000 centimeter cube or 1 dm cube. So from this now, let us now make use of the formula above. So we say that C1, since we are looking for C1 equals C2V2 divided by V1, and then our C2 is 0.0985 multiplied by our V2, which is 1000, divided by, we have all of this now, divided by our V1. Our V1 there is 50 centimeter cube. So doing the calculation of this now, what we'll be having there is going to be, we'll be having 6.5 divided by 50 will give us 97 moles per dm cube. So this is going to be the solubility of sodium hydrogen triazocarbonate. So our number 4 now, to calculate the volume of carbon dioxide that will be liberated from 1 dm cube of B if the titration were carried out at STP. That is what we have to calculate now. So volume of carbon dioxide liberated at STP, volume of carbon dioxide liberated at STP from 1 dm cube of B. This is the formula that we will use. Volume of carbon dioxide equals, we have concentration of B divided by the coefficient of carbon dioxide, which is our gas. Coefficient of the carbon dioxide multiplied by the volume in dm cube, volume in dm cube, and then multiplied by the molar volume of a gas, molar volume our CO2. So that is the formula that we will be using. So the volume of carbon dioxide at STP, our concentration of B, we calculated it previously to be okay, this is the concentration of B. We have our CB here to be 0.0985. That is what we will be using, 0.0985 multiplied by our coefficient of carbon dioxide. In our equation, we said it is a ratio 1:1, so carbon dioxide is 1, multiplied by the volume in dm cube. This is the dm cube that we are looking at, 1 dm cube, multiplied by molar volume of a gas is 22.4 dm cube. So doing all of these calculations now, we will have it to be 2.2064, and this value to 3 significant figures now, it will give us 2.21 dm cube. So this is going to be the value of carbon dioxide, or the volume of carbon dioxide that will be produced at STP. So for our question 3 now, A contains 0.90 grams of HCl in 250 centimeter cube of solution. B contains 8 grams per dm cube of XHCO3. Put A into the burette and titrate with 20 or 25 centimeter cube portions of B using methyl orange indicator. Repeat the titration 3 more times to obtain concordant titral values. Tabulate your results and calculate the average volume of acid used. From your results and the information provided, calculate the 1. Concentration of A in moles per dm cube, 2. Concentration of XH transocarbonate in B in moles per dm cube, 3. Molar mass of XH transocarbonate, and 4. Value of X. We have this as our equation as well, and we have to make use of 23.70 as the average titral value for this particular question, 23.70. So let us do that now. So we have to calculate the concentration of A in mole per dm cube. For us to be able to do that, we need certain information, probably the concentration of B in moles per dm cube. But since we do not have that, let us make do with what we have. We have this here to be the value of our gram per dm cube, but it is not in dm cube here, it is in 250 centimeter cube. So let us convert this to 1 dm cube first. Let us get this as our molar concentration, and then the mass concentration, and when we get our mass concentration, we can now calculate the molar concentration. So this is how we go about that. Let's start with finding the concentration of A in grams per dm cube. In grams per dm cube. From the question, it says 0.90 grams was dissolved in 250 centimeter cube. 250 centimeter cube. So X gram now, X gram will be in 1000 centimeter cube, which is also our 1 dm cube. So from this now, we can actually cross multiply, and when we cross multiply, we will have our X gram to be 0.90 multiplied by 1000 divided by the volume in which that particular substance was dissolved, which is 250 centimeter cube. So from this now, what we'll be having is going to look like, we'll be having 900 divided by 250. 900 divided by 250, and that is going to give us 3.6 grams per dm cube. So this is our mass concentration. Now that we have this one as our mass concentration, we can now use this one to calculate the molar concentration of the substance, which is actually the question we are told to calculate in the first instance. So concentration of A in moles per dm cube. So doing that now, we can now say mass concentration equals molar concentration multiplied by molar mass. That is going to be the formula that we will be using. So from here now, what we are looking for is molar concentration. So let's make molar concentration subject to the formula. Molar concentration equals mass concentration divided by molar mass. So now that we have that, our molar concentration, molar conc equals our mass concentration is also just calculated here to be 3.6 divided by the molar mass of HCl is 36.5. So our molar concentration equals 0.09863 to three significant figures now will give us 0.096 moles per dm cube. So this is going to be our concentration of A in mole per dm cube. And then we move to the next question, which is they said concentration of B in moles per dm cube as well. You can see it here, concentration of B in moles per dm cube, concentration of XHCO3 in mole per dm cube. So this is what we'll be doing. Concentration of B in mole per dm cube. So we use this formula CAVA over CBVB equals NA over NB. From here now, let's make it a straight line equation. We'll be having CAVANB equals CBVBNA, and what we're looking for is CB. So making it subject of the formula, we have CVANB divided by the coefficient of CB, which is VBNA. So from here now, we have it to look like our CA. We have calculated our CA. We said our CA there is 0.0986. 0.0986 multiplied by volume of acid used for this question. We're told to use 23 from the question. We're told to use 23.70. You can see that written down here, 23.70. So 23.70 multiplied by 1, which is the number of moles of acid, and then divided by our volume of base, which is 25, multiplied by 1. From here now, what we will be having is going to look like this. We have it to be 2.33682 divided by 2.3682 divided by 25, and that is going to give us 0.0934728. So three significant figures now is going to give us 0.0935 moles per dm cube. So this is going to be our CB. And then we move to the next question, which is our question 3. Question 3, they're talking about the molar mass of XHCO3. So molar mass of XHCO3. Now let's use this formula. Mass concentration equals molar concentration multiplied by molar mass. So if you are using that, and what we are looking for is the molar mass of this. So let us make molar mass subject of the formula. Molar mass equals mass concentration divided by the molar concentration. From here now, we are given in the question that the mass of B is 8 grams per dm cube. So that is what we'll be using here. So 8 divided by the molar concentration 0.0935. So from this now, we have it to be 85.56149, and these to three significant figures now. To three significant figures, we have it to be, it gives us 85.6 grams per mole. So this is going to be the value of our the molar mass of our XHCO3 in gram per mole. That is going to be the value. And then lastly, we have the fourth question there, which is asking us to calculate the value of X in XHCO3. Value of X in XHCO3. We have just calculated now, so let us make use of what we have. Use this formula. Use this formula where H is 1, carbon is 2, and oxygen is 3. Oxygen is 16. So we said XHCO3, the molar mass of everything that we have is what's just calculated now to be 85.6. So let us now calculate. We have X plus 1 plus 12 plus 16 multiplied by 3. Remember what we are using. We have hydrogen to be 1, carbon is 12, we have oxygen to be 16. So that is what we are inputting here. So we now have it to be X plus 1 plus, sorry, this is supposed to be plus 1 plus 12, that's 13, plus 16 times 3 is 48, all equals 85.6. 85.6. So from here now, X plus 13 plus 48 will give us 61 equals 85.6. X equals 85.6 minus 61. So X equals 24.6. So that is the value of our X in XHCO3. So that is as far as we can go on question 3. Alright, for question 4 now. A is a solution containing 3.50 grams of impure hydrochloric acid in 1 dm cube of solution. B is a solution containing 4 grams of sodium hydrogen tricarbonate in 500 cm cube of solution. Put A into the burette and titrate it with 20 or 25 cm portions of B using methyl orange indicator. Repeat the titration 3 more times to obtain concordant titral values. Tabulate your results and calculate the average volume of acid used. And then from your results and information provided, calculate 1. Concentration of B in mole per dm cube. 2. Concentration of A in mole per dm cube. 3. Percentage purity of HCl in A. And 4. Percentage impurity of HCl in A. Still using all of the parameters that we have here and our reaction for the equation, or the equation for the reaction, and we are to assume that our average titral value for this particular question is 23.80 centimeter cube. So without wasting much of our time, we go straight into answering that. So to calculate the concentration of B in mole per dm cube now, from our question, what we have there, they said A is 4.5 grams of impure HCl and B is a solution containing 4 grams of sodium hydrogen tricarbonate in 500 centimeter cube. So we need to first of all calculate our B in gram per dm cube before we can use it to get our molar concentration. So that is what we will do now. Concentration of B in grams per dm cube. So from the question, it said 4 grams equals 500 centimeter cube. So X gram will be in 1000 centimeter cube, which is also our 1 dm cube. So cross multiplying now, when we cross multiply, we have our x gram to be 4 times 1000 divided by 500, and that is going to give us 8 grams per dm cube. So this is going to be our mass concentration. If this is our mass concentration, we can now use this to get the value or get the answer to what we've been asked. So concentration of B in mole per dm cube. Concentration of B in mole per dm cube. The formula to use. We are using this mass concentration equals molar concentration multiplied by molar mass multiplied by molar mass. Since what we are looking for is molar concentration, let's make it subject of the formula. Molar concentration equals mass concentration divided, we have it divided by the molar mass, and that is going to give us something that looks like this. 8 divided by the molar mass of our salt is 84. So 8 over 84, and that is going to give us 0.0952 moles per dm cube. Moles per dm cube. So that is going to be the value of our B in moles per dm cube. And then we move to the next question, which is still talking about question 4. We have to look for concentration of A in mole per dm cube. Concentration of A in moles per dm cube. So we can make use of this formula, CAVA over CBVB equals NA over NB. So let's make a straight line equation out of it. So we have CAVANB equals CBVBNA. And what we're looking for is CA. So we have CA equals CBVBNA all divided by the coefficient of CA, which is VANB. So now that we have that, let's input our values. Our CB, what that we just calculated, 0.0952. We calculated it just now, 0.0952. that's what we'll be using. 952 multiplied by our VB 25 multiplied by 1, and then all this is divided by the volume of our acid, which is 23.80 multiplied by 1, which is our NB. So calculating this now, we'll be having it to be, all we'll be having there is going to be 2.38 divided by 23.0.100 moles per dm cube. That is going to be the value of our concentration of A. That is going to be our concentration of A in mole per dm cube. And immediately we go to talk about the third question, looking at the percentage purity of HCl. Percentage purity of HCl. So how do we get that now? Percentage purity of A. The formula to use. Percentage purity equals mass conc of pure substance divided by mass of impure substance divided by mass concentration of impure substance multiplied by 100 over 1. Remember, we are looking for mass concentration of pure substance, but look at the question. They told us that A is 4.5 grams of impure HCl. That is what we have there, but we need to calculate the mass concentration of the HCl first to be able to calculate the mass concentration of to be able to calculate the percentage purity. So what we do first and foremost is to calculate the mass concentration. Mass concentration equals 0.100 multiplied by 36.5. That is what you should be having there. So when we do the calculation here, so we'll be having 365 divided by 4.50, and that is going to give us 81.111. So to three significant figures, it will be 81.1%. So that is going to be the percentage impurity. And for us to get the percentage purity, let me just put that here. Percentage impurity equals 100 minus percentage purity. Percentage impurity equals 100 minus percentage purity, and so we have 100 minus 81.1, which is going to give us, what we'll be having is going to be 18.9%. So this one here is the percentage purity, and here is percentage impurity. That is what that question is looking like. So don't forget that we have all of these, our acid and our base titration, and these are sample questions that have been treated. I will encourage you to try as much as possible to go through what we have discussed, learn all of these things that have been talked about, and I wish you success in your examination. If you are yet to subscribe to our channel, don't forget to do so. Subscribe to our channel, like our content, share them with your friends, let them also benefit from what you are getting. Thank you very much, and bye for now.